Hello and welcome to A-Level Math. This is the first video in the series Geometric Progressions. In this video, we are going to cover the idea and intuition of geometric progressions from the very scratch. So you don't need to have any prerequisite or any additional knowledge to understand this particular topic. It is independent of any other topics. And we'll be understanding how the formula for the geometric progressions is derived, and we'll be taking some solved problems. So let's start. Remember that how in AP we started with defining the first term of any progression by A, and in the case of AP we had D as the common difference. But in case of geometric progressions, we have the concept of something called common ratio. So let me first give you an example of arithmetic progression. This was something of like an arithmetic progression. So 1, 4, 7 and so on and so forth. This was an arithmetic progression because we see that in each of these terms we are constantly adding this 3. So this 3 was called as the common difference. Now suppose I give you this progression 1, 2, 4, 8, 16. So what pattern do you see over here? The pattern is that I constantly multiply 2 in the preceding term to get the next term. So I multiply 2 in this one to get 2. I again multiply 2 to this term to get 4. I again multiply 4 to this term, 2 to this term to get 8, and so on and so forth. So this 2, the 2 means the factor with which we are constantly multiplying. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So this 2 is called as the common ratio. So common ratio is that number by which we are constantly multiplying the preceding number. In the previous example for arithmetic progressions, we were constantly adding this number from the preceding term, but in here we constantly multiply this number to the preceding term. This is what is the basic difference between an AP and a GP. So AP have a concept of common difference and GP have a concept of common ratio. Okay, so assume that I give you the first term as A and I say that my constant ratio is R. That means I'll have to multiply R to get the next term. So AR will be my next term. And again I'll have to multiply R to this preceding term to get the next term. This will give me AR square. And then again multiplying with a factor of R will give me AR cube, and so on and so forth. Okay, now the question is that I want to find out some general term over here. What will be the formula for some, say, nth term for this geometric progression? Just like we have a formula for the nth term of an AP, we want to have a general formula for the GP. Okay, so let's observe some pattern. For the first term, we are not having any R, so we can write this as A into R to the power of 0. For the second term, we are having R to the power of 1. So you see that it can be written as R to the power of 1. For the third term, we are having a power of 2. For the fourth term, we are having a power of 3. That means the pattern is we are having power of 1 less than the rank of the term. So suppose if I ask you to find out the 50th term, it will be A R to the power of 49. That means the rank of the term. So if I want to find out T50, it will be A times R to the power of 49. That means 1 less than the rank of the term. So if I want to find out the nth term, it will be A times R to the power of n minus 1. This is the formula for the general term of the GP. So this gives me the formula for the general term of the GP. Tn, nth term, is A, which is the first term, multiplied by R, which is the common ratio, to the power of n minus 1, where n is the rank of the term. Let's take up some questions now. Find the 10th term and the general term of the progression, this thing. Okay, so we asked to find out T10. I know that the formula is A into R to the power of 9 because 1 less than the rank of the term. A is my first term, which is 1 by 4 in this case. So it is 1 by 4 and R is the common ratio. Okay, so R is the common ratio means we have to find out which number is multiplied to 1 by 4 to get minus 1 by 2. In a similar to put it simply, I just want to find out minus 1 by 2 divided by 1 by 4. Okay, so this will give me minus 1 by 2 times 4 by 1, which is equal to minus 2. So if you observe, if you multiply minus 2 to this term 1 by 4, you will be getting minus 1 by 2. Also, if you again multiply minus 2 to this term, you will be getting 1. If you again multiply minus 2 to 1, you will be getting minus 2, and so on and so forth. So to put it simply, if you want to find out r, all you need to do is just divide the second term with the first term. Just like you remember what we did to find out the common difference, we used to subtract, we used to find out the second term minus the first term. So in a similar way, we just have to do second term divided by the first term. So my r I get as minus 2 over here. So minus 2 to the power of 9. So this is my 10th term. I can find the value of it, which is, okay, let's do it like this. I can write this as minus 2 the whole squared times minus 2 to the power of 7. Now minus 2 square is actually 4, so 4 and 4 gets cancelled out. All I am left with is minus 2 to the power of 7. If you want, you can even simplify this. So, I will be getting minus 2 to the power of 7. So, what is minus 2 to the power of 7? 2 1s are 2, 2 2s are 4, then 8, 16, 32, 64, 128. So, 2 to the power of 7 is 128. So, this is my answer. So, T10 is minus 128. Now, they are asking also to find out the general term of the progression, which is Tn. So, what is Tn? A r to the power of n minus 1, which is 1 by 4, because a is 1 by 4, r is minus 2 to the power of n minus 1. Now, I can write this 1 by 4. This 4 I can write as, okay, 1 by 4 I can write as 2 to the power of minus 2. Okay, because 4 is 2 to the power of 2 and 1 by 4 is 2 to the power of minus 2. So, minus 2 to the power of n minus 1. And then I can take minus 1 outside, so it is minus 1 to the power of n minus 1, and then 2 to the power of minus 2 and n minus 1 I can combine. So I get minus 1 to the power of n minus 1, 2 to the power of n minus 3. This is my answer for the general term of the GP. Next question. Show that the progression, this thing, is a GP. So all we need to do is just check whether the common ratio is constant or not. So what we need to do is, first of all, divide this by this. So we'll be getting the constant ratio or the common ratio, and then we again need to do this divided by again this same the same term, and then again we need to do this divided by this and verify that all of these ratios are actually turning out to be the same. So root 2 minus 1 by 2 root 3 divided by 1 doesn't give us anything new, so it is just root 2 minus 1 by 2 root 3. Then what we need to do, we need to divide the third term with the second by the second term. So 3 minus 2 root 2 divided by 12 divided by the second term will be actually 2 root 3 divided by root 2 minus 1. So I have just multiplied with the reciprocal of it. So now I need to verify whether this thing is turning out to be the same as this thing. Okay, so 2 6 are okay. Now 6 can be written as 2 root 3 times root 3, because root 3 will give me 3 and 3 into 2 is 6. So I can cancel 1 root 3 with this. So I am left with 3 minus 2 root 2 divided by 2 root 3 multiplied by root 2 minus 1. So I guess some more simplification is required. So you see that 3 minus 2 root 2 can actually be written as root 2 minus 1 the whole squared. So I can write down this 3 minus 2 root 2 as root 2 minus 1 the whole squared divided by 2 root 3 times root 2 minus 1, and then one of these will cancel out. So actually I am getting the same common ratio. Okay, now the fourth term divided by the third term will give me 5 root 2 minus 7 divided by 24 root 3 multiplied by 12 time 12 divided by 3 minus 2 root 2. Okay, so 12 2s are 24, so it's 2 root 3, we are getting 2 root 3. Okay, now we have to manipulate this 5 root 2 minus 7 and 3 minus 2 root 2. So I just have a I already know that this 3 minus 2 root 2 is root 2 minus 1 the whole squared, so I definitely should be getting 5 root 2 minus 7 to be equal to root 2 minus 1 the whole cubed. So you just verify in somewhere in the rough whether root 2 minus 1 the whole cubed is turning out to be 5 root 2 minus 7, because it's only then that these two this with this will cancel out to give me root 2 minus 1. So it has to be root 2 minus 1 the whole cube, because this is already root 2 minus 1 the whole squared, and we already know that we want it to be something like this. So this is some sort of a cheating that you can do in the examination, because you already have the answer in your hand. So root 2 minus 1 the whole cubed is a cubed minus 3 a square b plus 3 into a into b square minus b cubed, which gives me root 2 the whole cubed is 2 root 2 minus 3 times root 2 square. Root 2 square is 2 times 3 is 6 minus 3 root 2, sorry, it's plus 3 root 2 minus 1. 3 root 2 plus 2 root 2 gives me 5 root 2 minus 6 minus 1 gives me minus 7. Okay, so I'm getting it. So I can write this as root 2 minus 1 the whole cubed divided by 2 root 3 times 1 by root 2 minus 1 the whole squared. So I cancel these out and 1 root 2 minus 1 is remaining. So root 2 minus 1 divided by 2 root 3. So this is a GP. So this way you can prove that this entire progression is a GP, because their constant ratio is actually turning out to be the same. Now we need to find out its fifth term. To find out the fifth term, we know that T5 is equal to a r to the power of 4. A is 1, so we put a is equal to 1, and r is root 2 minus 1 divided by 2 root 3 whole to the power of 4. Okay, so what we actually do is just open up this square, or what you can simply do is that even there is a simpler solution. We know that this is the first term, this is the second term, this is the third term, and this is the fourth term. So the fifth term will be just this thing multiplied by the common ratio, which is root 2 minus 1 by 2 root 3. So you just multiply this constant ratio to this fourth term to get the fifth term. So I leave this to you as an exercise. You please try it out and check whether your answer is correct or not. If the fourth and ninth terms of a GP are 54 and 13122 respectively, find the GP. Okay, so they are saying that the fourth term is 54 and the ninth term is 13122. We need to find the GP. That means we need to give the entire progression with its 4 or 5 terms written out. So what is T4? We know that T4 is a into r cube, which is equal to 54, and T9 is actually a into r to the power of 8, which is equal to 13122. Now we need to solve for a and r, because just like for an AP we need to have a and d, for a GP we need to have a and r. If you can find out the value of a and r, then you can write down all the terms of the GP. So we need to simplify, so and actually solve. So in order to solve, we divide this equation number 2 with this equation number 1 and see what happens. So a into r to the power of 8 divided by a into r to the power of 3 gives me 13122 divided by 54. A and a cancels out, r to the power of 3, r to the power of 8 cancel out to give me r to the power of 5. So r to the power of 5 is equal to, I need to cancel out in here as well. So 2 plus 2, 4, 5, 6, 7, 8, 9. So it is cancelling out by 9. So 9 6 are 54, 9 1s are 9, 41, 9 4s are 36, 36 minus 46, 41 minus 36 is 5, 52 9 5 is 45, 72, 9 8 is 72. Okay, is it again cancelling out with 3, 5, 6? Yeah, so we can cancel out with 6. So 6 2s are 12, 25, 6 4s are 24, 18, 6 3s are 18. So r to the power of 5 is actually 243. So now we'll have to find out some number which on raising to the power of 5 gives us 243. So that's actually 3. We know that 3 to the power of 5 is actually 243. So we get that r is actually equal to 3. So we get the value of r. Now all we need to do is just plug in it in any of these equations. So I'll choose the first one because it will be easier then. So a into 3 to the power of 3 will give me 54. So a times 27 is equal to 54. So a is equal to 54 by 27, which is actually equal to 2. So I got the value of a, I got the value of r. I now can write down the GP. So my a is 2, then r is 3. So the next term will be 2 times 3, which is 6. Next term will be 6 times 3, which is 18. Next times will be 18 times 3, which is 54, and so on. So this is my GP. Now they are asking you to find out its general term. Okay, so we need to find out its general term. General term is Tn, which is equal to a times r to the power of n minus 1. So a is known to us, 2, r is 3. So it's 2 times 3 to the power of n minus 1 is my answer. This is the general term. Tn is equal to 2 times 3 to the power of n minus 1 is the general term for the given geometric progression. If the first and the nth term of a GP are a and b respectively, and p is the product of its first n terms, then prove that p squared is equal to ab whole to the power of n. Okay, so we are given that the first term of the GP is a and the nth term of the GP is b. So first term is a and the nth term, that means Tn is equal to b. By default we take the first term to be a only, so there's no problem in that. So nth term is b, that means a times r to the power of n minus 1. So you please do mention in your examination that we are assuming, let us assume that the common ratio is r. You have to make this disclaimer before you are using this r in your answer. So because I'm lazy, I'm not doing that. So but you please you do. So a times r to the power of n minus 1 is equal to b. So I have got the value of b in terms of a. Okay, and now p is the product of its first n terms. That means p is equal to the product of all the first n terms. So that means a into ar into ar square. So let me use brackets, it will be helpful, up to all the way up to the nth term, a into r to the power of n minus 1. So this p is the product of the first n terms. Okay, so let's simplify this. How many terms are there in all of these? There are n terms, right? Because the question already says that we have to take the product of n terms. So there are in all n terms. That means we are having a into a into a n times. So I'll just split it, a into a into a. I have it n times, and then r's power is going to be added. So r's initial power is starting from 1, then 2, then 3, all the way up to n minus 1. So I'll be getting this on simplification. A times a times a is actually a to the power of n, and r to the power of 1 plus 2 plus 3. So you, if you know that this is actually an AP, 1 plus 2 plus 3 up till n minus 1, this is actually an AP with the first term as 1, the common difference as 2 minus 1, which is equal to 1, and the number of terms is n minus 1, because from 1 to n minus 1 you are having n minus 1 terms. So sum of these n minus 1 terms is actually, you remember the formula, n by 2 times 2a plus n minus 1 times d. Okay, so it's n minus 1 by 2. So in place of n I'm writing n minus 1 because that is the number of terms. It's 2 plus n minus 2. So 2 and 2 cancel out. I get n times n minus 1 by 2. Okay, so r to the power of n into n minus 1 by 2. Okay, now they are saying that we have to prove that p square is equal to this thing. So let's square both sides first of all and see what we get. So p square is equal to a to the power of 2n times r to the power of n into n minus 1. So what I did, I just multiplied 2 to each of these powers. That's how it works, right? So p square is equal to this. Now we need to show that this actually a b to the power of n. So what is b? This is b. So what is ab? So from here we can get that ab. From here we get that ab, we just multiply a on both the sides, so we get it to be equal to a square b to the power of r to the power of n minus 1. And now whole to the power of n, so we do whole to the power of n on both the sides, so I get a r to the power of 2n, a to the power of 2n and r to the power of n into n minus 1. So these things are actually turning out to be the same. ab to the power of n is the same thing and p square is also the same thing. So we get that ab to the power of n is actually equal to p squared, and hence proved. Next question. The m plus nth term and m minus nth terms of a GP are p and q respectively. Show that the mth and the nth terms of the GP are these and these. Okay, so we are given that t m plus n is equal to p and t m minus n is equal to q. So what is t m plus n? It is a r to the power of m plus n minus 1, this is equal to p, and a r to the power of m minus n minus 1 is equal to q. In a similar way, just in the previous examples, I divide the second equation with the first equation, or anything, you by the first equation by the second equation, doesn't matter, and a will be eliminated and we will be able to find out the value of r. So we divide these two. So because I'm a lazy person, so I'll do it this way. Okay, so a and a cancel out and I get r to the power of m plus n minus 1 minus m plus n plus 1, because this entire power of r will go up with the change of sign. So minus m plus n plus 1 is equal to p by q. M and m cancel out, minus 1 plus 1 cancel out, we get r to the power of 2n is equal to p by q. Okay, so r is equal to p by q to the power of 1 by 2n. So this is the value of r. Now put on this value of r in any of these equations. So let's take the first one. So a into, what is the value of r? P by q to the power of 1 by 2n multiplied by m plus n minus 1 is equal to p. So a will actually be equal to p divided by this entire thing, p by q to the power of m plus n minus 1 by 2n. So now what we can do is we split the powers on p and q and then we can segregate on the powers of p. So we get p, this power is actually 1, and then minus m plus n minus 1 by 2n divided by q to the power of, did I do something wrong? So this q will go up, right? So q will not be in the denominator, qb will be in the numerator. So multiplied by q to the power of m plus n minus 1 by 2n. Okay, so now p, 2n LCM, 2n minus m minus n plus 1 into q to the power of m plus n minus 1 by 2n. 2n minus n cancel out to give us n. So p to the power of n minus m plus 1 by 2n into q to the power of, this is multiplication, so into q to the power of m plus n minus 1 by 2n. So we have got the value of a and we have got the value of r. All we need to do is just find out the value of tm and tm and tn, because that is what is required. So let's quickly find it. So what is, okay, let me clean up some stuffs. So what is Tm? Tm is equal to A into R to the power of m minus 1, which is p to the power of n minus m plus 1 by 2n times q to the power of n plus m minus 1 by 2n. So this is the value of A. Now R is p by q to the power of 1 by 2n. So merging all the powers, I can write it like this. And now I segregate the powers of p and q. So p n minus m plus 1 by 2n plus m minus 1 by 2n times q to the power of n plus m minus 1 by 2n times minus m minus 1 by 2n. So this gives me p to the power of minus m plus m cancel out, minus 1 plus m cancel out. So this gives me n by 2n into q to the power of m and m cancel out, minus 1 cancel out. I get n by 2n. So I get p to the power of half times q to the power of half, which is actually root over p times root over q. So in a similar way, you can find out the value of Tn by putting the formula Tn is equal to, so Tn is equal to A into R to the power of n minus 1, and then put on the value of A and R and simplify and check whether you are getting this answer or not. Okay, I leave it to you as an exercise. Next question. Let S be the sum, P be the product, and R be the sum of the reciprocals of three terms of a GP. So they haven't mentioned which three terms should we take. So let's take any consecutive three terms. No, let S be the sum. Are they saying consecutive? Let S be the sum, P be the product, and R be the sum of the reciprocals of three terms of a GP. Yeah, three terms of a GP means three consecutive terms. So let us assume that the three terms are A by R, A, and AR. So the advantage, remember that when we did the questions on AP, and whenever we were asked to find out some three terms of an AP, we always used to take them in the form of A minus D, A, and A plus D. Similarly, you could have also taken this GP as A, AR, and AR square, but taking them in this way gives us an additional advantage, and you will soon come to know what advantage do we get on taking these numbers as GP and not these numbers A, AR, and AR square. These are also in GP with A as the first term and R as the common ratio, and this is also in GP with A by R as the first term and R also the common ratio, but this gives us some advantage. So I'll tell you what advantage we get. So they're saying that P be the product of all these terms. So we know that P is the product of all these terms. That means P is equal to A by R into A into AR. The advantage is that R and R cancel out and we get P is equal to A cube. That means we are not getting R, we are just getting something in terms of A. So this helps us and gives us a bit of convenience because we are only dealing with one variable A and not two variables A and R. So we have got P is equal to A cube. Now what is S? S is the sum of all these terms. So S is equal to A by R plus A plus AR, and they are saying that R is the sum of the reciprocals. So R is equal to the sum of the reciprocals, that means R by A plus 1 by A plus 1 by AR. So these are the values of P, S and R, and now we need to prove this thing. Okay, no problem. So we are already having P, and now they need P square. So what we do, we square both sides, so we get P square is equal to A to the power of 6. A cubed the whole square is actually A to the power of 6. Now S cubed, so S we already have, we can take A common in here, so we get S is equal to A common 1 by R plus 1 plus R, and now I can take R as LCM, so I get R LCM 1 plus R plus r squared. Okay, now what is s cubed? So s cubed is equal to a cubed by r cubed 1 plus r squared the whole cubed. So this is s cubed. Okay, now what is r? Let's also simplify r. So r is equal to, we can take 1 by a common, so we'll be getting r plus 1 by r. So let me take r as LCM over here. So we get r square plus r plus 1. So I can write r as, this gives me r is equal to 1 by a r square plus r plus 1. So what is r cubed? So r cubed is equal to 1 by a cube r cube r square plus r plus 1 the whole cubed. So what is the left hand side now? Left hand side is p square r cube. So p square r cube is actually this thing multiplied by this thing. So the left hand side is a to the power of 6 into this entire r cube. So a cube r square plus r plus 1 the whole cube. So a cube and a power 6 cancel out. So this is actually a cube by r cube. This entire thing is actually s cube. So we get the right hand side. So LHS is equal to RHS, hence proved. Okay, the pth, qth and rth terms of an AP as well as those of a GP are A, B, C respectively. They're saying that there are three terms A, B, C which are both in AP as well as GP. Okay, so if three terms A, B, C be the pth, qth and rth terms of an AP. So if A, B, C are the pth, qth and rth terms of an AP, then we get TP is equal to A, TQ is equal to B and TR is equal to C. And what is the pth term of this AP? Okay, so we cannot take the first term of this AP to be small a because that is already taken in the question. So let us assume that capital A is the first term of our AP. So the formula is now A plus P minus 1 times D, where D is the common difference of the AP. Now this is actually A. Similarly, A plus Q minus 1 times D is equal to B, and A plus R minus 1 times D is equal to C. So the AP part is done. Now they are saying that they are also in GP. So what is the pth term of the GP? Again, we cannot take the first term of the GP to be A. So assume that it is X. So X into the common ratio also we cannot take as R because R is already taken as the rank of some term. So let's assume that the common ratio is what should we take? Common ratio, we say that common ratio is alpha. Okay, so alpha is this Greek letter. So alpha to the power of P minus 1 is equal to A. X into alpha to the power of Q minus 1 is equal to B, and X into alpha to the power of R minus 1 is equal to C. So these are the facts in our hand. Now we need to prove that this thing holds. Okay, so A to the power of B minus C times B to the power of C minus A and something something something. Okay, so first let's do one thing. Let's first of all find out this B minus C. What is the value of B minus C, which we can derive from these two equations. I subtract these two, so I do this equation minus this equation. So A and A cancel out and I get D Q minus R is equal to B minus C. Also I need to find out C minus A. So for finding out C minus A, what I can do is I can subtract this from this. So I'll be getting D common R minus P is equal to C minus A, and to find out A minus B I can do this minus this. So D common P minus Q is equal to A minus B. So I've got the value of B minus C, C minus A and A minus B. So let me try to put it in this left hand side. Okay, so what is my LHS? My LHS is a to the power of b minus c, which is d times q minus r, into b to the power of c minus a, which is d times r minus p, into c to the power of a minus b, which is d times p minus q. So a times, okay, so what is a now? I can put down the value of a from here. So x into alpha to the power of p minus 1 is my a, whole to the power of d into q minus r, into what is b, x to the power x into alpha to the power of q minus 1 whole to the power of d into r minus p, and x into alpha to the power of r minus 1 whole to the power of d into p minus q. So we need to simplify this and see what we get. So let me make a bit of space. So we get x to the power of, so what we can do, we can segregate all the powers of x. So x to the power of this into x to the power of this into x to the power of this is actually x to the power of the sum of all these. So x to the power of dq minus dr plus dr minus dp plus dp minus dq, and then alpha to the power of p minus 1 into this plus q minus 1 into this plus r minus 1 into this. So alpha to the power of p minus 1 into d times q minus r, d times q minus r, plus q minus 1 times d into r minus p, plus r minus 1 times d into p minus q. So these all the powers of x are cancelling out, minus dr plus dr minus db plus db minus dq plus dq. So we get x to the power of 0. Also, I leave it to you to verify that if you simplify all of these powers of alpha, you will also get 0. So we will be getting x to the power of 0 times alpha to the power of 0, which is 1 into 1, which is 1. So that is how we prove it. So please complete this. Next, if x, 2y and 3z are in AP where the distinct numbers x, y, z are in GP, then find the common ratio of the GP. So we have to find out the common ratio. So let's assume that the common ratio is r, and we are given that x, y and z are in GP. That means if we assume that r is the common ratio, that I can write y is equal to xr, because if I assume r is the common ratio, that means y is got by multiplying some number to x. I assume that number is r, so xr is actually y, and similarly z is equal to yr, because I assume that r is the common ratio, so I mean that y on multiplied with r will give me z. So that is how I can write these things. Also, putting the value of y, I can write it as x into r, which is xr square. So I get these results. Okay, so x is x, y is xr, and z is xr square. Now they are saying that x, 2y and 3z are in AP. That means 2y minus x is equal to 3z minus 2y, because if these three numbers are in AP, that means 2y minus x, which is the common difference, should be equal to 3z minus 2y. So I can take y on one side, so I get 2y plus 2y is equal to 3z plus x. So 4y is equal to x plus 3z. Now all I need to do is put down the value of x, y and z. So y is xr, x is x, and z is xr square. I can take x common and cancel from each side, so I get 4r is equal to 1 plus 3r square. I get a quadratic equation in terms of r. So 3r square minus 4r plus 1 is equal to 0. So 3r r minus 1 minus 1 and minus 1. So I get this on factorization. So 3r r square minus r minus 3r minus 4. Yeah, this is the factorization. So I get two values of r. So 3r minus 1 equal to 0 gives me r equal to 1 by 3. Sorry for this. So r is equal to 1 by 3 and r minus 1 equal to 0 gives me r is equal to 1. Alright, so I have now two values of r and these are my answer. R is equal to 1 by 3 and r is equal to 1. So the common ratio is found out. Next, if A, B, C are in AP, B, C, D are in GP and 1 by C, 1 by D, 1 by E are in AP, then show that A, C, E are in GP. Okay, so A, B, C are in AP means what? B minus A is equal to C minus B. That means 2B is equal to C plus A. Equation number 1. Next, B, C, D are in GP means what? C by B is equal to D by C because the common ratio is constant. So C by B should be actually D by C. So I get BD is equal to C square. Equation number 2. Next, 1 by C, 1 by D, 1 by E are in AP. So in a similar way, I'll be getting 2 into 1 by D. So 2 into 1 by D is equal to 1 by C plus 1 by E. Similar to this logic from equation number 1. So this is my equation number 3. Okay. So using these three, I have to prove that A, C, E are in GP. That means my target is to reach here. I have to show that C square is equal to AE. If I can show this, then ACE are in GP. Okay, so how to do that? Okay, so we start with this. C square is equal to BD. So C square is equal to BD. Now I have the value of B from here and I have the value of D from here. I just put it in here. So what is the value of B? B is actually C plus A by 2. So B is C plus A by 2. What is the value of D? So let's first simplify this. 2 by D is equal to EC by E plus C by EC. So this gives me D is equal to 2EC by E plus C. So I put down this value, 2 into E into C divided by E plus C. Alright. Now 1C and 1C gets cancelled out. So I get C times E plus C is equal to 2. 2 and 2 can also get cancelled out. So 2 and 2 cancel out. So no 2 over here. now if you observe that P by Q square, from here we get that P by Q and right by R. So I actually get what is required. So we get D by P minus Q plus 2. Okay, we at equal to words you can do twice of this plus this. Anyway, you'll be getting the same thing because and all this is AR minus A and A square minus this is just AR, I'm sorry, AR square AR. So now I can AR on so 2AR square minus Oh, sorry, this is minus 4 by 3. Okay, I thought this is minus 3 by 4. So the answers are minus 4 by 3 and minus 3 by 4. These are my common ratios. So if I take minus 4 by 3 as my common ratio, then my AP becomes A by R, that means minus 1 by minus 4 by 3, then minus 1, and then AR, that means minus 1 into minus 4 by 3. On simplification, this gives me 3 by 4 comma minus 1 comma 4 by 3. And if I take minus 3 by 4, then I get minus 1 divided, okay, let me write it down over here, minus 1 divided by minus 3 by 4, then minus 1, and minus 1 into minus 3 by 4. So on simplification, I get 4 by 3 minus 1 and then 3 by 4. So just in the reverse pattern. Okay, so these are my two sequences in GP. Next question. Find three numbers in GP whose sum is 13 and the sum of whose squares is 91. So let's quickly write down the terms. A by R, A and AR. The sum is given to be 13, so A by R plus A plus AR is equal to 13, and the sum of whose squares, that means the square of the first term plus the square of the second term plus the square of the third term, is equal to 91. So I have two equations, equation number 1 and equation number 2. I need to solve these to get the value of A and R. Okay, so let's square on both the sides of this thing. So I get A by R plus A plus AR, the whole squared is equal to 169. So now A plus B plus C, the whole squared, is A square plus B square plus C square plus 2 into AB, which is A by R into A, plus BC, A into AR, plus CA, A by R into AR, is equal to 169. Now this is known to us, it is 91. So 91 plus 2 into A square by R plus A square R plus A square. R and R cancels out, so this is 169. So 91 can be taken to the other side, so 2, and A square we can take common, so 1 by R plus 1 is equal to 169 minus 91, which is 78. 2 also I can take to the other side, so this gives me 2 3s are 6, 18, 9s are 18. Okay, now if I take A common over here, I get the value of 1 by R plus 1. So if I take A common over here, I get 1 by R plus 1 plus R is equal to 13. So this is actually equal to 13 by A. So I get A square into 13 by A is equal to 39. So this gives me A is equal to 39 by 13, which is 3. So I get the value of A to be equal to 3. Now I just need to put down the value of A over here in this equation to get the value of R. Okay, so A is 3. So 3 into 1 by R plus 1 is equal to 13. Alright, so 3 by R into R plus 1 plus R square is equal to 13. So 3R square plus 3R plus 3 is equal to 13R. 3R square, 3R minus 13R is minus 10R, plus 3 is equal to 0. 3 3s are 9. So 3R square R, so minus 9R. So 3R square common, 3R minus 3 and minus 1 is equal to 0. So 3r, sorry, this is 3r. 3r square minus 3r, okay, this will be minus 1 and this will be minus 3. So 3r square minus r minus 9r gives me minus 10r plus 3 is equal to 0. So r is equal to 1 by 3 and r is equal to 3. So don't worry how I do factorization, you just do it yourself the way you factorize it. You multiply 3 and 3, 9, and then write this 10r as 9r plus r and then do the factorization. I am bit habituated with jumping steps, so I'm comfortable, but you can do that much on your own. So I've got two values of r is equal to 1 by 3 and r is equal to 3. So all you need to do is, now that you have the value of a as equal to 3, and you take first this value of r and find out those three terms, and then take this value of r and find out again those three terms. That will be your answer. Next question. The sum of three numbers in GP is 56. So let's quickly take the numbers to be okay, so here we can take the numbers to be even ar and ar square, because they are not asking us to find out the product. So let's take those, okay, let's take them the same, okay, no problem. A by r, a and ar to be my three numbers. So the sum of these three numbers is 56. So a by r plus a plus ar is equal to 56. And now they are saying that if we subtract 1, 7 and 21 from these numbers in that order, that means a by r minus 1, a minus 7 and ar minus 21, these form an AP. So if they are in AP, that means twice of this is actually this plus this. So twice of a minus 7 is equal to this a by r minus 1 plus ar minus 21. Okay, now we have two equations. The first equation is this, the second equation is this, and we need to find out the values of a and r. Alright, so 2a minus 14 is equal to a by r plus ar minus 22. So we can club minus 14 and minus 22. So minus 22 plus 14 on the other side. So plus 14. So minus 22 plus 14 is so minus 12, and it's actually 8. So it's minus 8. So 2a is equal to a by r plus ar minus 8. Alright. Okay, so how do we eliminate any one? Okay, what we can do is take minus 8 on the other side. So what we have, 2a plus 8 is equal to a by r plus ar. Now what we do, we add a on both the sides. So what do we get? 3a plus 8 is equal to a by r plus ar is actually 56. So this is 56. So 3a is 56 minus 8, which is 48, and a is equal to 48 by 3. So we have got the value of a, and all we need to do is now put down this value of a on here and find out what is the value of r. So a is 16. So a by r plus a, okay, so a is 16. So a by r plus ar is equal to 56. 16, we can take a common. So a 1 by r plus 1 is equal to 56 by 16. So what is 56 by 16? 224, 4 ones are 4, 16, 4 4s are 16, 4 4s are 16, 2 and 7. So 7 by 2, there will be no a over here. So now r square plus r plus 1 divided by r is equal to 7 by 2. So 2r square plus 2r plus 1 is equal to 7r. 2r square minus 5r plus 1 is equal to 0. Sorry, this will be 2 and this will be 2. So now we can write it as 2r r minus 1 minus 2 is equal to 0. So it's 2r square minus r minus 4r minus 5r plus 2 is 0. So we get the two values of r to be r equal to 2 and r equal to 1 by 2. And in a similar way, now you can find out the three numbers. So they will be, first you'll have to take r equal to 2 and then take r equal to 1 by 2. Okay, that's it. Thanks a lot for studying with A-level maths. Study hard, study smart, and keep pushing your limits. Thanks a lot. Bye bye. Stay tuned with A-level maths.